Okay, so in this video lesson, I want us to talk about the electron configuration of the magnesium ion, which is a cation specifically. In our recent video lesson, we talked about the electron configuration of the magnesium atom itself. Now is the time for us to talk about its ion, the configuration of its ion. So we have the magnesium atom here with electron number of 12, but here the +2 indicate that it has lost 2 electrons, and as a result the third shell is no more there because there is no electron for it to occupy. So we have up to the first and the second shell, the first taking 2 and the second shell taking 8 in that order. So it means that in the magnesium ion we have only 10 electrons and not 12 electrons as in the magnesium neutral atom. So let's see how we can write, or how we are supposed to write, the electron configuration of the magnesium ion. Okay, so electron configuration for the magnesium ion. Don't forget that magnesium has an electron number of 12, but in this case it has lost 2 of 8 electrons, remaining 10. So the proton number exceeds the electron number by 2. Alright, so magnesium, you know that the first shell, we have the 1s orbital. Okay, so principal quantity number 1, and then angular momentum is equal to 0, which is the x orbital, and it can take a maximum of 2. You've learned that already. If today is the first time coming across this video lesson, please, below this link we have the previous video lessons there. Watch them to get the concept. All right, so we have the 2s also taking 2. From the 2s we move to the 2p, which also takes 6, since it is degenerate and it consists of 3 subshells, each taking 2, 2 each, so 2, 3, 6. All right, so this is the electron configuration for the magnesium ion, that is magnesium that have lost 2 electrons. Okay, so let's see for the condensed, the expanded configuration. You have the 1s2, the 2s2, 2px, 2py, 2pz, so 2, 2, right, making 10. Lastly, let's talk about the Bohr notation. So 1x, have the 2x, we have the 2px, 2py, 2pz. Okay, so we have spin up, spin down, right? Spin continue number. Okay, clockwise, anti-clockwise, clockwise, clockwise, clockwise. Why? Because Hans rule says that the degenerate orbital must be first filled singly with power electrons before pairing begin in the opposite direction. So we pair opposite direction, opposite direction, opposite direction. So this is how the electron configuration of the magnesium ion will be. Now let me add up by, let's say we have magnesium that have lost only 1 electron. Okay, yes, so you have 12 here, so meaning this magnesium is having 11 electrons. You have 1s taking 2, 2x taking 2, 2p taking 6, and then 3x having 1. Okay, so you get the other to be 1s2, 2s2, 2px2, 2py2, 2pz2, 3x1. Alright, and the Bohr's notation. So the magnesium, when magnesium loses one electron, its configuration will be just like that of sodium element, just as that of sodium element. Yes, so let's see. All right, okay, degenerate orbital. So you have spin up, spin down, spin up, spin down, right? Spin up, spin up, spin up, spin down, spin down, spin down, spin up. Okay, so this is what the configuration will be when magnesium loses only one electron to form magnesium plus. That is the first ionization energy. Yes, and the first one that we did was the second ionization for magnesium atom. Okay, so we will end here. I'll still create a lot of examples on the electron configuration, including the transition element, in order to enable you to grab the concept well. As we proceed, we realize that there are some level of abnormality or discrepancy within the electron configuration, most especially when it reaches the transition element like chromium and copper, just to mention but few. Stay blessed. Don't forget to subscribe to the channel. You are at the right place.